Okay, so I did a lot of the work ahead of time just because I'm having a bunch of technical issues. So I will walk through the steps, but I've already transferred everything, wrote everything, and saved it 1,000 times. Um, I'm doing exercise 14.1 about bicycle helmet use. And step one is to create our scattered plot. I already did that right here. However, I will walk through the steps. So we're going to go ahead and go to our data set. We're going to click graphs, down to legacy dialogues, down to scatter dot. I'm going to go with a simple scatter. I'm going to define my X value is the number of students receiving reduced and free lunches, where my Y value is the percentage of students wearing helmets. And then my marker is going to be school names. I don't think I didn't need to use any titles or options at this time. Okay, I'm going to hit OK. Once again, I did already transfer this data into my Excel, but as you can see here by the shape as it goes downward, it is showing a negative trend with the exception of this one right here, which happens to be Los Orbos school, which later on we will remove the outlier. Okay, the next step is we want to run our descriptive statistics, explore. And in this one, our dependent is the percentage of students wearing that. Our factor is this, I believe, possibly. We're fine with the outliers. We want to get rid of the stem and leaf, and we actually want to do a histogram and then plot for normalcy. Okay, I'm gonna go ahead and plot. Oh, no, I did it wrong, I think. Yeah, I did it wrong. Sorry, 1 second. Let me try this again. I'll do the correlation first. Our variables is putting the reduced lunch and then the helmets. Parsons, I don't think we need to do any of the options. Okay, so I'm gonna go ahead and hit OK. And then this gives us our R value. Well, including the outlier, our R value is currently negative 0.581, which is indicating it is moderately strong correlation right now because it's closer to -1 and further from 0, which is a good thing. But when we remove the outlier, it becomes stronger. Now I will go into descriptive statistics explore. I'm trying to remember. I did this already, but I'm not remembering correctly. Nope, I got another warning. I know you hate when I play the video at the same time. I do apologize, but I kind of need to. I don't know why I'm not doing it correctly this time. I ran it perfectly fine. I did the correlation. Now I'm trying to do explore. Okay. Students receiving, students wearing. Nope, still getting the warning. I'm sorry.
Explanatory variable, which is our cigarette consumption. that has been common throughout basically our entire practice, except for like a chi-square and and with like the t-test and the assumption or the ANOVAs, we test those assumptions, and we know that it's based on the country, so that way
So I ran the
I
scatter
haven't
plot.
tested this one out, and it's been a while since I've done, especially for something like this. All right, so once we have all that set up, hit OK, and what do we got? Well, it looks like, I don't know if you were a kid and you had like one of those, like it was filled with water and those little like green.
Okay.
Okay. So
Explore. So I'm not doing something correctly. I'm not sure why. Let's get out of that. So analyze, descriptive statistics, explore. Okay. I need both of these. Oh, snaps, wrong button. Both of these into this. Okay. Go to plots, make sure it's just histograms, get rid of that, test for normalcy. Okay. I'm gonna go ahead and hit OK. There we go. Whew, starting to wonder for a second. Okay, so things we want to pay attention to is the skewness and the standard error, and then the quartus in the standard error. We have a significance level, so it was not normal. As you can see on here, the percentage of students who receive reduced lunches, their lines, their plots, the box plot, which looks pretty normal. And then those who wear helmets, quite different. Their box plot. Okay, so now.
We did that visually. That's nice. That's a good visual check. Next, we need to actually look at the numbers. So we would go to our descriptives and explore 1950. I actually missed that part.
So I did put all this information in my Excel. Although I could shrink it and put them closer side by side to make it a direct comparison.
That this was actually 1950. Oops. All right, we'll move forward. All right, so negative 6, then it's like, oh, that's a little bit too skewed for my taste. That's what we're looking at. You can do these for both variables.
Okay, so now, like I said, we know what our R value is. It was the negative 5.81. So I'm going to go ahead and go back to our data. And the only way I know how to actually get rid of the outlier is to just delete the information, unfortunately. So now I'm going to go ahead and go back, run our correlation, same thing. Okay, and then just in case I'm putting the Spearman on because that's what we did in the video. Oh, maybe I didn't want to do the Spearman. No, I did. Okay, so our new R value, once we remove the outlier, is negative 0.849, which is making this go from a moderate correlation to a strong correlation between those who receive reduced meals and the percentage of students wearing helmets. Okay, so that information on our non-parametric test, it's a little bit different. So I'm going to minimize that, and I'm just going to go over my data now. Make sure I cover everything. So here was my plot, my scatter plot. Okay, the outlier. Based on the angle of the scatter plot, this is a negative linear relationship. Los Arbelos may be an outlier. It was located in the top right hand of the plot. We had no missing data. When we ran our descriptive statistics originally with the outlier, our R value was negative 5.81, which is right here. indicating that it was a moderately negative significant level. Once we removed the outlier, our new data indicated that our R value was negative 0.849, which then switched it with an N of 12, making it go from a moderate negative level to a strong negative level. The data reflects this with a more negative trend. My hypothesis, the question is there a correlation between students wearing a helmet and students who receive reduced or free meals? The null hypothesis is no, there is no correlation between them. The alternative is yes, there is a correlation between them. I did copy over my test statistics, showing we had no missing data, that our stuff was not normal. The plots, the histograms, scrolling down, I did remove the outlier. Like I said, okay. Our p-value was smaller than 0.001, which means at the alpha level 0.05, it was significant. At the alpha level 0.01, our data is statistically significant. So my conclusion is the correlation test was ran to see if there are any correlations between the students who wear helmets and the students who receive reduced or free meals. The evidence provided to have a strong correlation between those students, with the exception of the outlier. We removed the outlier, which allowed the evidence to switch from moderate correlation level to strong correlation level. The data had an R value of negative 0.849 with an N of 12. Once the outlier was removed, the p-value was smaller than 0.001, making this statistically significant at the alpha level of 0.001. Therefore, we reject the null hypothesis. All right, I hope I answered it well enough. Sorry I had some issues. I hope that's acceptable. Once again, I've been having technological issues for days now, Zoom and then Aporto, but I can only do everything in Aporto. So thank you very much. Have a wonderful day.